Welcome to lesson 3 of GMAT Math Basics. Today, I want to talk about fractions. When we talk about fractions, really what we're doing is expanding on our previous conversation about division. Fractions are a really useful way of expressing division. They're also really useful because some values don't fit neatly into integers. Division and fractions help us represent these values that are in between. For example, what if I want to charge more than $1 for something, but less than $2? Well, it's really helpful to have numbers that fit between those two integers. 1/2, 3/7, 5/9 are all good examples of really useful values that fit between 1 and 2. More often than not, you'll use technology to help with fractions in the real world, but there's no calculator on the GMAT quant section. There is one on the GMAT data insights section, but no calculator on the GMAT quant section. So it's very worth understanding some best practices for dealing with fractions by hand. First, let's start with the basics. How do we depict fractions? Again, I'm going to use this question style for these lessons. So this becomes kind of like your digital bank of flashcards that you can come back to over and over again to test yourself on these basics if you find that helpful. So how do we depict fractions? Fractions are numbers that are written as one thing divided by another thing. What's being divided goes on top of a line, and what is doing the dividing goes on the bottom of that same line. So it's kind of like two lines of text, one on top of the other, where the top line is underlined. Usually the line is equally spaced between the top number and the bottom number, but the whole like top line underlined with one number right below it is, I think, a helpful visual analogy. Last week, we talked about the dividend and the divisor. The dividend goes on top of the fraction line, or what's sometimes called the fraction bar, and the divisor goes below that line. Typically, the quotient will be on the other side of an equal sign next to the fraction. For example, 6/2, or 6 divided by 2, if I wanted to write that as a fraction, I would write 6 on top with a line below it with a 2 under that line. 6 divided by 2 equals 3, so we would typically write an equal sign next to the fraction. It usually goes right next to the line itself, and we would write 3 on the other side of that equal sign. So that's how we depict fractions. Next, what is a numerator? A numerator is another name for the top of the fraction, what goes above the line. What is a denominator? A denominator is another name for the bottom of the fraction. That's what goes below the line. Next up, how do we operate on fractions? This is really, really important for great GMAT scores. The simplest operation to do with fractions is multiplication. So ask yourself, do you know how to multiply fractions? When you multiply fractions, you just multiply the tops by the tops and the bottoms by the bottoms. It's pretty much the simplest operation we can do with fractions. You could also express that as saying you multiply all the numerators together, and then you multiply all the denominators together. And whatever the resulting product of all the numerators is the numerator of the new fraction, or the product of all those fractions multiplied together. And the product of all the denominators is the denominator of the product of all those fractions. Couple examples. 1/2 times 1/3, or 1/2 times 1/3. On top, it's just 1 times 1. So that equals 1. On the bottom of the fraction bar, we would do 2 times 3, and that equals 6. So the result of 1/2 times 1 over 3 is equal to 1 over 6, or 1/6. You usually speak fractions with a th at the end instead of a ds. So we talked about place values earlier in the program, and I talked about place values that were integer place values. So hundreds, ones, tens, 100,000s. Those typically end in ds. Non-integers, fractions, typically end in a th. So 1/6 instead of 1/6. Or if I had 1 divided by 100, that wouldn't be 100s. That would be 100ths. We'll go deeper with that naming convention when we talk about decimals in a future lesson. For now, back to multiplying fractions. Another example. 2 over 3 times 3 over 4, or 2/3 divided by 3/4. You'll notice that thirds end with a ds. Hence our desire to save the intricacies of that conversation for another lesson and not cloud our conversation about fractions too much. I promise we'll circle back to that. So 2/3 times 3/4. On top, you have 2 times 3. That's 6. On the bottom, you have 3 times 4, and that's 12. So the result would be 6 over 12, or 6 divided by 12, or 6/12. All of those strings of words I just mentioned represent the same value, which is 6 with a bar below it, with a 12 below that bar. That's how you multiply fractions. You multiply all the tops, and you multiply all the bottoms, and that gives you your new top and your new bottom. Now that you understand how to multiply fractions, we can progress to more complex operations, which are typically going to involve multiplying by fractions. What do I mean by that? Well, ask yourself, do you know how to add fractions? Addition of integers like 3 and 5 is pretty straightforward for most people. You can probably imagine 3 apples in a basket and 5 apples get put into that basket, and now hopefully you can visualize there are 8 apples in that basket. And we'll get into how to add larger integer and fractional values by hand without a calculator later. But here I'm just talking about relatively small integer operations that our minds can typically grasp onto. But adding fractions can be a little bit more involved. In order to add fractions without a calculator, you'll usually want to find something called a common denominator. For example, if I want to add 1/2 plus 1/3, or I want to add 1/2 and 1/3, those have different denominators. It's best to think that if there are different denominators in the fractions you're adding, that you will not be able to add them by hand. Now, obviously, this is not the case in real life and or with calculators. Like in real life with a calculator or with an AI or whatever you like to use, you're going to be able to just ask it to produce 1 over 2 plus 1 over 3, and it will probably give you a great answer very quickly. But by hand, I've found it's better to just think that that is not possible. Even though it is technically possible, it's best to just think, maybe you should just think it's a bad idea. Obviously, if you've gotten great results in the past with a different process than what I'm about to recommend, then by all means, keep doing what you're doing. But I'm making this series for those of you who haven't added fractions by hand in quite some time, and you might be very interested in, okay, well, how do I actually do this? So let's return to this concept of the common denominator. A common denominator just means that we are making the denominators the same. How do we do that? Well, we do that with a clever way of multiplying by 1. Let me talk about what I mean by that. We talked about multiplication as a basic operation in the previous segment of the program. And you might recall that Multiplication is adding the same number over and over. But we also talked earlier just now about 1 times something, multiply something by 1. And when you multiply something by 1, it's just the original thing. How does that work? Well, 1 times anything is the original number because we're not counting 2 or 3 of that thing. We're just counting it 1 times. I'm counting this thing 1 times. 1 times 3 is just 3. If I count 5 once, it's just 5. 1 times 5 is 5. 1 times 10 is 10. 1 times 34.7 is 34.7. It's just one of that thing. That's a good way to think about that. Why do we care about that? Why does that even matter? Well, when we're adding fractions, we want to change the denominator, again, so we can make it the same, but we don't want to change the value of the fractions that we are adding. We still want them to retain their original values. We just want them to look different, and we want them to have the different look of having a common denominator. Let's return to our example of 1/2 plus 1 over 3. If I multiply 1/2 by 2, I get a completely different number. I don't want that to happen. If I multiply 1/2 by 1, I get the same number. So again, we're going to multiply by 1 in a clever way. And this way we change the way the fraction looks. We make it easier to work with. We get the denominator that we want without changing the actual value of the number. This is kind of a cool trick. If I want to add 1/2 and 1/3, I will multiply 1/2 by 3 over 3. Now, in a future lesson, I will explain why I chose 3 over 3. But for now, let's just pretend you knew why I did that. So I'm going to multiply 1/2 by 3 over 3. Recall that when we multiply fractions, we just multiply tops by tops, and we multiply bottoms by bottoms. So on top, 3 over 3 times 1 over 2 will be 3 times 1 on top, and 3 times 2 on the bottom. And the result will be 3 over 6. Then we will do something very similar to 1 over 3. We're going to multiply by 2 over 2. So on top, we get 2 times 1, and on bottom, we get 2 times 3. And the result of that is going to be 2 over 6. So again, what I've done is multiplied 1 over 2 times 3 over 3, and then I've multiplied 1 over 3 times 2 over 2. And that makes both denominators 6. That's how we get a common denominator. In this way, we transform 1/2 into 3 over 6, and we transform 1 over 3 into 2 over 6. And now we're going to be able to use another cool trick to add those fractions. It's always great news when fractions have the same denominator when you want to add them, because once you have the same denominator, you just add the 2 tops. Or if you're adding more than 2 fractions, you just add all the tops, and you keep the bottom the same. So when you're adding fractions with the same denominator, you add all the tops and you keep the bottom the same number. So in this case, 6 is going to be the bottom of the result. All right, so if I have 3/6 of something, and you have 2/6 of that same thing, and we put those two quantities together, we will now have 5/6 of something. So we add the tops, 3 plus 2, and we keep the bottom the same, 6. That's how you add fractions. Again, you find a common denominator, usually by multiplying by 1 in a creative way. And then once you have the same denominator, you just add the numerators and keep the denominator the same. That's adding fractions. Next up, how do we subtract fractions? Great news here. It's very similar to adding, except once you have the common denominator, you just subtract the tops and keep the bottom the same. So 1/2 minus 1/3. We're going to multiply 1 over 2 by 3 over 3. We're going to multiply 1 over 3 by 2 over 2. Same thing we did before. 1/2 becomes 3 over 6. 1/3 becomes 2 over 6. And then we subtract the tops. So 3/6 minus 2/6 equals 1/6. If I have 3/6 of something and I lose 2/6 of it, I have 1/6 of that thing left. Again, you just find the common denominator and subtract the tops, and you keep the bottoms the same. That's how you subtract fractions. Again, in a future lesson, we'll talk more specifically about how I knew to make the bottom 6 and how I knew I should multiply 1/2 by 3/3 and 1/3 by 2/2. So don't worry about that if that's not 100% clear right now. We are going to come back to that, and I promise you will understand and hopefully appreciate why we have laid things out in this order. So that's how you multiply, add, and subtract fractions. Finally, how do we divide fractions? It's kind of interesting. We actually don't divide fractions when we do this by hand. Again, it would be different with a calculator or some type of machine assistance. So if you have a calculator or a spreadsheet that can do math, then you can just punch in 1/2 divided by 1/3 and it'll spit out a great answer for you. But again, it's best to think that when you're doing it by hand, that is not a good plan of action. Again, unless you're getting really great results with the way that you're doing it. I don't recommend it. Instead, I recommend flipping the fraction that is doing the dividing. All right, and I'll define what I mean by flip in a sec. You flip the fraction that's doing the dividing, aka the divisor, and we multiply by the flipped version of that fraction instead of dividing by the original version. There's actually quite a bit of theoretical math behind why this works, and it is almost certainly overkill for the GMAT. So rather than digging into exactly why and how all this theoretical stuff can be done, I recommend just memorizing that this is how it's done when you're dividing by fractions. And for sure, if you want to know more, by all means, go for it and dig deep on it. But the whole purpose of this series is not to sandbag you and your prep with a bunch of theory that's not actually going to help your GMAT score. I'm assuming most of you are not here because you're passionate about arithmetic and are looking to take your arithmetic skills to the next level for the sake of that skill. You're probably here because you're passionate about business and you want to take your business skills to the next level. And arithmetic just happens to be a means to that particular end. Definitely let me know if I am wrong about that. That is my current assumption that I'm operating on. So here's what I recommend memorizing. When I divide by a fraction, take what's doing the dividing, flip it, and multiply by the flipped fraction instead. Excuse me. Here's what I mean by flipping. Let's say we're going to divide 2/3 by 3/4. Notice that 3/4 or 3/4 is doing the dividing. So we are going to flip that, and by that I mean we are going to make it 4/3 instead of 3/4. We're going to take the denominator, put it in the numerator. We're going to take the numerator, put it in the denominator. Okay, take what's on top, put it on the bottom. Take what's on bottom, put it on the top. That's what I mean by flip it. So again, we don't divide by 3/4. Instead, we multiply by 4/3. Sometimes that flipped version of the fraction is called the reciprocal. That's a term that might come up on the exam. The reciprocal of a fraction is the flipped version of it. It's the numerator on the bottom and the denominator on top. The original numerator goes below the line. The original denominator goes above the line. That's the reciprocal. It's kind of crazy, but it actually yields the same result as dividing by the original fraction. You can try it on a calculator if you'd like to. It's a pretty cool little trick, and it makes doing division by fractions by hand without a computer intelligence to aid you a lot easier, in my opinion. So let's return to 2/3 divided by 3/4. That's actually the same thing as 2/3 multiplied by 4/3. And when we multiply, you'll probably recall we just multiply top times top and bottom times bottom. So we would get 2 times 4 on the top, that's 8. And we would get 3 times 3 on the bottom, that's 9. And so the result is 8 divided by 9. 2/3 divided by 3/4 equals 8/9. Let's try a couple examples. What's 1/3 divided by 5/6? I'll repeat that in another way. What's 1/3 divided by 5/6? What's doing the dividing gets flipped, then we multiply. So 1 over 3 divided by 5 over 6 becomes 1 over 3 times 6 over 5. 1 times 6 goes on top, and 3 times 5 goes on the bottom. So the net result is 6 over 15. That's how you add, subtract, multiply, and divide fractions. Next time, we'll go further with fractions by talking about how to make dealing with them and operating on them easier and faster. Until then, I look forward to it. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video presentation on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and stay positive and stay consistent with your studies. Talk to you all soon.